Notes on log applications and equations. Solve each equation, round your answers to the nearest hundredth. Alright, so we're going to do the equations part first. So we're going to solve for the piece that has x involved. So I'm going to add 6 to both sides. 14 to the x minus 8 equals 68. And now, to get this x out of the exponent, I need to convert it to a logarithm. So, log base 14 of 68 equals x minus 8. And there's no good way to put this into your calculator unless it's base 10, so we have to use the change of base formula. So, log base 68 over log of 14, log of 68 over log of 14 equals x minus 8. If you put this into your calculator, there's a log button if you have a graphing calculator on the left side. If you have the calculator on your phone, if you turn it so that your phone is long ways, a lot of times you'll have a log button. But you should get approximately 1.60 since it says to round to the nearest hundredth. 2 spots after the decimal, and then we can add 8 to both sides, and your answer will be 9.60. Okay? Same deal with this guy. We're going to isolate this logarithm, so it looks a little confusing without the parentheses. I really like having the parentheses in it. But we're going to subtract 8 from both sides, and that's going to give us log base 3 of 10n equals 3. And then this one we're going to have to convert into an exponential so we can get the of by itself. So 3 to the third equals 10n. 3 to the third is 27. And when we divide both sides by 10, we get that n equals 2.7. Alright, on to the applications. So, students participating in a psychological experiment attend several lectures on a subject and were given an exam. Every month for 2 years after the exam, the students were retested to see how much of the material they remembered. The average scores for the group are given by the human memory model, blah, 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 where T is the time in months. And since it's for 2 years, that is why, let's do that. Since it's for 2 years, that's why we go to 24 months. Alright, so the average score, sorry about the weird transition. Okay, what is the average score on the original T equals 0 exam? So we're going to substitute 0 in for T. F of 0 equals 82 minus 5 times the log of 0 plus 1. So since there's nothing written for the base number, it's base 10, which means you can directly type this into your calculator just like this. 82 minus 5 times log of 1. When you do that, you should get 82. And of course you'll write your answer in a sentence because you're just that good. And you know that if you don't, Holly will be very angry with you. And bad things will happen. Like zombies. Alright, so, how do I get that to scoot over? Ah, there we go. Woohoo, fancy. We'll sneak it up there so you can see it. Alright, so that's my answer. Alright, on to this guy. What is the average score at the end of T equals 6 months? Well, then we're just going to plug 6 in. Not a big deal. Substitute it in. 82 minus 5 log base 10 of 6 plus 1. You can just add that and make it 7 in your calculator, and it should give you 77.77. Once again, you should be writing this in a sentence. So, make sure that you do. You should get the average score after 6 months was 77.77. And then, this last one here, after how many months will result in the average score of 79? That's written really confusing. It means after how many months will the average score be 79. So in this one, they're giving you the score, so that's the F of T. So we got to do 79 equals 82 minus 5 log base 10 of t plus 1. And we need to solve, just like we did in 1 and 2, for the logarithm. So we're going to subtract 82 from both sides. And that's going to give us negative 3. And then we're going to divide through by that negative 5. To get 0.6. And since our variable here is inside the of, we're going to need to convert it. So I'm going to write in a 10 because I think it makes it a little bit easier to convert. So it's 10 to the 0.6 equals t plus 1. 10 to the 0.6 you can put into your calculator and it will give you 3.98. And then you just subtract the 1 over. So 2.98 really gives you about 3 months. Okay? And then again, write that as a sentence. Alright, so after 3 months, the average score will be 79. I'm not sure if it's percentage or not. Seems like you could put a percent on here, but it doesn't state that. Alright, last one. Nice and quick. Suppose that you invest $5,000 in a savings account. How long will it take you to double your money? 5% interest compounded annually. Remember, annually means yearly. Interest means you're adding 5% to your 100%. So you're looking at 105%, and then you turn it into a decimal. It's a growth problem. So in this one, our initial value is 5,000 times our 1.05 to the t or x or whatever variable makes you happy. I guess I should probably be consistent with it and not change it because that would make more sense. And then they want you to know when it will double. Well, 5,000 doubled is 10,000. And you solve this one as well. So when you divide here, you should get 2. Yes, it's going to always do that because it's doubling. If it was tripling, it would turn into a 3. You can use that shortcut if you'd like to. Because x is in the exponent, I need to convert it. So this is log base 1.05 of 2 equals x. And then you need to change the base. Log of 2 divided by log of 1.05, and that should give you approximately 14.21 years. Well, since this is happening annually, your answer would look something like this. Our money will double between the years 14.